Good morning, good afternoon, everyone. Welcome to the Avi Networks webinar with Mirantis. My name is Ashish Shah, and with me is Craig Peters from Mirantis. Welcome, Craig.
Thank you, Ashish. I'm looking forward to this.
So let's get started. This webinar will be recorded, and you will get a copy of the recording in a couple of days. So the topic for today's webinar is building enterprise-grade OpenStack cloud. Within a few short years, what we've seen is OpenStack has become the de facto open source cloud orchestration platform. We have thousands of developers actively contributing to making OpenStack more robust and feature-rich, and hundreds of enterprises and cloud service providers deploying OpenStack. With what started as a platform for experimental projects has now become a reliable orchestration platform for today's private and public cloud deployments. Despite this, we still have a few shortcomings that get in the way of enterprises deploying OpenStack for business-critical applications in production environments. And in this webinar, we'll discuss those and how Mirantis and Avi Networks are coming together to solve them. So let's kick this off, and we'll start with what are some of the common use cases that we are seeing with OpenStack. And I'll hand it over to Craig for that.
Thank you, Ashish. So I just want to share a few thoughts on what we're seeing in our customer in the marketplace. So we see all kinds of enterprises adopting OpenStack because it provides their IT organizations with a kind of agility that allows them to do many different things with a common set of hardware and allows them to deliver value to their customers much more quickly while taking advantage of the cost advantages of the agility and the ability to take advantage of underlying infrastructure choices that they can make, choosing high-end servers for some applications, white box servers for others, and really tuning their investment based on the application. And the kinds of use cases that we're seeing a lot of adoption for are kind of outlined here in this slide. So for example, we have many organizations who want to speed up development and increase the quality of development and the flexibility of the environments in which they're doing that development. And they use OpenStack to develop a cloud in which they operationalize DevOps. And that's the notion of providing developers self-service and automated tests, and based on those automated tests, then deploying to staging, performance labs, and production in an automated way where you have central control over who has what rights to do what, and making sure that that's repeatable and has a high throughput.
Makes sense.
And that's really taken off in a lot of different kinds of organizations where everybody needs to compete. You have taxi companies competing with Lyft and with Uber and all that, right? So they all need to work that way. So we also have telco companies who are doing something called network function virtualization. And the idea here is that these companies want to get away from having to invest in special purpose hardware for very focused functions within telco networks and virtualizing that. So essentially making it all software driven and using OpenStack as the infrastructure for automating how they deploy these services based on demand. So for example, you don't want to have cell phone towers and regional hardware set up to support the infrastructure required for the World Cup. That's a hugely costly thing to do for special events. You want to, in your data center, be able to dynamically deploy or allocate machines to handle the software to provide those same functions.
Right.
And that's the whole notion of NFV. The third one that we're seeing a lot of adoption on is really around IT as a service. And this is where public cloud is really driving competition for IT organizations. So IT organizations have the choice to either kind of become the manager of outsourced web services and essentially keep track of that, or to provide those services internally and therefore keep control and gain the other benefits that we've talked about that OpenStack brings. And that's a huge area and very broad.
Yeah, I think, if I may interject, I think we've seen that in our customer environment as well, as the CIO says, well, why should I go to AWS?
Yeah.
Build an AWS-like elastic environment on-prem if you can. So I think this is absolutely a very common use case we as well see.
Absolutely. And then the last one is everybody's trying to take advantage of all this data. So everything is creating data. We're all trying to get value out of it. And there are two approaches there. One is to have dedicated clusters where you're tuned perfectly to doing exactly just data processing. The problem there is that those infrastructures then face the same constraints that the telcos are facing with network function virtualization. You've specialized hardware to do one kind of thing. And it turns out if you do the cost-benefit analysis, the flexibility of being able to dynamically provision clusters to do certain kinds of processing on a schedule, say when you need to do monthly reconciliation of your accounts, that has had huge payoff for some of our customers. So those are the big use cases.
Makes sense. Even here, you need an elastic infrastructure where periodically you need to just put in more resources, but not over-provision for all the time. So
and big data is a classic example of that.
Excellent. So as we see these use cases, Craig, what are some of the challenges that you see in the environment? And as we go into those challenges, and let me know if you've also seen a similar kind of journey with OpenStack. So for example, when we talk to our customers, they say that, well, the way we start OpenStack deployment is that we'll start with a pilot in a lab and make sure that it'll work for applications. And at that point, they need the visibility or the monitoring to say, yes, my application SLAs are being met, especially when I go from a dedicated rack for a particular application to a shared cloud environment. Then what we see is as they get comfortable with the pilot, they move into production with an initial set of applications. Again, what they want to make sure that is that you can get availability, resiliency, security of a dedicated infrastructure that they're used to for these business critical apps, but in a cloud environment. And finally, at least what we've seen is the hardest for enterprises is the last stage, which is how do we do this at scale, right? Because I have hundreds or thousands of applications. I want to have full automation, as we talked about, right? I want an elastic infrastructure like AWS, which is I should be able to on-demand scale out the applications, deploy new applications, have self-service capabilities to my departments, just as if they were tenants. And I think that's where the operational simplicity and scale comes in. From your customer experiences, how does this journey relate from your point of view?
It matches completely, and really, if you think about it, it's not surprising, especially as OpenStack is evolving. So it's roughly a 4.5-year-old project now, and as you mentioned, it's got a huge number of contributors, and the different parts of the OpenStack infrastructure have matured at different rates,
right.
And you have different demands on it. And as the projects have evolved, different parts of it have scaled. So for example, Nova, you can scale very large and can manage a very large number of virtual machines, but the connection between that and, say, the Neutron networking components is where you start seeing some of the interesting things going on. So the one of the big adoption curve changes that's happened over the last year is that you'll notice that more and more large enterprise deployments are relying on software-defined networking controllers.
Right.
And so we've seen this where some parts of the OpenStack infrastructure, and this is the beauty of OpenStack, it's pluggable by nature, by design. It's intended not necessarily to take over all functionality. It allows you to plug in for your use case specific functionality. So if you need to scale a network in a way that, say, Neutron on its own is not initially designed to or currently capable of doing, then you can plug in another capability to do that. So that class of activities is what's getting us through the gap that you have illustrated here between these kind of production initial apps and getting it to be multi-department, multi-application deployments.
Makes sense. So now let's switch gear a little bit and talk about the challenges, and we'll talk about in two categories. First, in terms of OpenStack deployments, as you see in large customer environment, what are those challenges that you see when your customers want to get ready? Say, yep, I have an OpenStack initiative, but what do they face?
Sure. So I've kind of outlined here the kind of major dimensions of issues. One is around complexity, another is around scale, as we've already kind of touched on a little bit, and the other is about the rate of change of the project itself. Right. So essentially, in terms of complexity, the biggest challenge is that there are many projects that make up OpenStack, and that set of projects is growing all the time. And then the ecosystem of people who are participating, there are many plugins, many extensions, lots of different ways to skin a cat.
Right.
And that choice introduces challenges in how you consume it. The next is in scale, right? So scaling by nature is hard, and as soon as you have lots of components and interconnections, You scale that only is an exponential function, right?
That's
and
right.
so it makes it that much more challenging. And then finally, because OpenStack is such a diverse and active community, and there are actually 2 major releases of OpenStack per year, it changes very quickly, and it makes it very hard to consume as an organization, as an enterprise, all of the new advances that come in OpenStack over time. And so, as we go through this, we'll talk about how we address those challenges.
Sounds good. So I think the other set of challenges that as we see comes in those application SLAs. As we've already touched upon a little bit earlier, once you have an OpenStack cloud deployed, how do I guarantee my application SLAs? How do I make sure that what I'm used to getting in a dedicated environment is I'll still get that from availability, visibility, and just elasticity point of view. So I've outlined some of the challenges here. First is on the visibility front. Today, you have different tools for different level of visibilities. You have infrastructure tools for infrastructure monitoring, network, servers, storage, and so on. You have some for user level visibility, right? Who's coming in, and so on, and where they're coming from. And then there's application level visibility. So you have tons of tools, but there are no tools that's giving you an end-to-end true picture that says, okay, this is how my end users are experiencing the application, and this is how the application is performing. Mm-hmm. So I think that's one clear challenge that's even exacerbated when you go to a cloud environment. And the next set of challenges are around the application availability, the classic application delivery and load balancing related ones. And the reference implementation, the LBAS implementation that OpenStack has, which is HA proxy, it's clearly not HA. Unlike the name that says HA proxy, it itself runs as a process on the Neutron node, which is a single point of failure. And it's also a best effort service. It doesn't really provide any guarantees of any sort. A second challenge with the default implementation is that it lacks advanced features. Not the least of is SSL, but other high-end load balancing features such as content-based redirection and so on.
Correct.
Which the enterprises are used to getting in traditional load balancer and ADC appliances. So pretty soon, what we see our customers do is they play with HA proxy and they say, "Oh, I need the legacy of traditional ADC solution," which itself comes with its own challenges because those solutions were never designed for cloud. Remember, those were designed for your 3-tier network architecture where such an appliance would stay at the aggregation layer, and for the north-south traffic, it's a perfect place. The traffic goes through those and load balances the application. With today's enterprise applications, which has primarily east-west traffic, this becomes a single choke point. So there's a lot of traffic tromboning that happens, especially if you have a big monolithic appliance through which all the traffic has to flow through, and that becomes a performance issue. It's also a scaling issue, right? Because to scale the performance, it's not an elastic where you just add another instance immediately, right? There are logistical challenges, there are licensing issues. So it's complex and it's expensive if you try to now do multi-tenant. Every tenant get its own appliance? Even with virtual appliances, you have a proliferation of individual virtual ADCs, if you will, that you have to manage. Yes. So what you need is a next generation solution for cloud environments, which really solves these challenges. And in next couple of slides, we'll address those. So let's now go back and see how we address these challenges. And Craig, from the first set of challenges on deployment side, can you share what Mirantis is doing, and then we'll talk about what Avi is doing, and then we'll switch to a demo.
Yeah, we'll show how that works together. Absolutely. So what Mirantis is focused on is providing a distribution of OpenStack that is super easy to configure. It's extremely open, and it allows you to deploy and manage your cloud in a robust enterprise-ready way. So the distribution includes a deployment technology called Fuel, which allows you to either via an API or a UI, if you're really just getting started, create your first cloud, deploy to a rack or 2 or 3 to get your first cloud up and running, and then manage that cloud over time. So it handles post-deployment checks. It does things like handle patching and upgrading of OpenStack. And the key thing here is that it encapsulates a reference architecture. So OpenStack in and of itself, with all of these different projects and capabilities, has hundreds of thousands of different combinations of things you could do with it. And the problem with that is that only some small subset of them actually work out of the box. So what Fuel does is it allows you to have a known good deployment. It has a reference architecture built into it, so when you deploy, you know you will get a working cloud. It has all the checks built into it so that you'll be up and running smoothly. And that's that architecture is then, we do performance engineering on that to assure that it'll run at a scale of hundreds of nodes. So the next piece of that is, how do I then get workloads onto my cloud? How do I operationalize this in my organization? So you need to be able to share the work that your developers are doing, so you can easily create a catalog within OpenStack. The project is called Murano, and it exposes a lifecycle management for applications, which enables you to do basically two major kinds of things. One is to deploy traditional applications like databases or content management systems, web publishing type systems, things like that. Or it allows you to dynamically configure services that are going to run within your cloud that your applications will consume. So the whole idea is that modern applications today are actually composed of lots of different components. Murano is a catalog of all these different components and gives your developers a self-service portal or a set of UIs where they can consume that to compose their application. Then those APIs are what drives the integration to make this a continuous delivery platform. So CI/CD systems like Jenkins or TeamCity essentially consume these APIs to drive the automatic deployment of applications for test or to production once they've passed all their tests.
Yeah, and actually we'll do a Murano demo how we can deploy a web set of applications with load balancing services.
So this hits on exactly how together we're going to solve these problems. We're
That's
providing
right.
the flexible infrastructure, and we're making a self-service way for applications to consume these kinds of services. And so, I just want to quickly run through what is the Mirantis OpenStack distribution. So we take core OpenStack, we harden it. So we go through lots and lots of testing. We fix many, many bugs. We wrap it with a deployment engine, which allows you to automatically plug in with certified hardware drivers. So Avi and us are working together to certify your driver in Mirantis OpenStack, and we expose this for the developer as a set of Murano applications and OpenStack APIs that then is operationalized through Fuel for automatic deployment and operation of those clouds. So we have plugins. So we're also working on a plugin so you can automatically deploy the Avi Networks
That's right.
software alongside your cloud as an integral part of your cloud. So the whole idea is so that you have an easy to consume, easy to deploy distribution with a rich ecosystem of partners who provide the best-in-class services, and it's tested, reliable, and supported cloud.
Thanks, Greg. Fantastic. Let's now switch gear and see how Avi's playing a role in the overall solution. What Avi's built is a next-generation ADC that's optimized, built, architected for cloud. It integrates visibility and analytics. We'll see that in the demo. And it provides the classic load ADC functionality, which is load balancing, application security and acceleration, as well as real-time application monitoring and analytics. Whether your workloads are in on-prem cloud or a public cloud, whether your users are coming from mobile or desktop, it provides a seamless experience. Let's go a little deeper into the Avi solution itself, and then also talk about how it integrates with OpenStack, which is something that's different from other solutions. So at the heart of the Avi solution is the Avi Controller. This is the brain of the system. As you can see here, the solution is built on an SDN architecture. So the controller is a centralized control plane for policy management and also runs the big data analytics engine. This is also the single point of integration with the rest of the ecosystem, including OpenStack. The distributed data plane, or what we call service engines, are the micro ADCs. They're the ones which are providing load balancing, acceleration and security services. Also, they act as hundreds of data collectors, collecting hundreds of metrics every second and pushing them up to the controller. These service engines are running in tenant context, as we'll see here in OpenStack, and they're elastically scaling out and scaling in response to real-time user demand. And finally, on top of the controller is our Avi UI that's built on the REST API. REST API is a first-class citizen in our product, which means the only way to talk to a product is REST API, even for CLI. The controller integrates directly with OpenStack services. So as a load balancing solution, of course, we have an LBAS driver that's part of the Neutron service. That's how you can use Horizon to configure load balancing policies. This is how Murano integration also works, which is calling the LBAS APIs indirectly. But also we have deep integrations with Nova and Keystone as well. So the Avi controller on demand spins up service engine VMs through Nova, then uses Neutron to plumb these service engine VMs in the right network. The controller also uses Nova to scale out and scale in automatically. And then we use Keystone for user authentication. So when the user logs into the Avi controller, they can actually, the user, the tenant, the role information is synced directly from Keystone. So it has deep integration with OpenStack. Another way to look at Avi's solution is with a simple picture like this, which is a legacy load balancing solution really runs outside of core OpenStack cloud. Whether it's a physical appliance or even a virtual appliance, the load balancing is really a device that is external to the OpenStack cloud. With Avi, on the other hand, the service engine VMs are really part of the OpenStack cloud itself. And that's how, by fitting inside OpenStack, we provide that elastic scale-out scaling experience. So that's another way to see how Avi is different. Avi also offers flexible deployment options, and the most common deployment option is what I have highlighted here, which is a multi-tenant deployment that's common with both enterprises and cloud service providers. So in this case, as you can see on the right-hand side, the Avi controller runs in the admin or the provider tenant, and that's where the centralized control plane is. The Avi service engines, or the data plane, are actually running inside the user tenants. So each tenant gets its own set of service engines or dedicated data plane that's isolated from another tenant. So you have multi-level multi-tenancy here. On the data plane side, the dedicated group of SCs or service engines are auto-provisioned based on that tenant's policies. Each tenant can independently scale that application delivery and analytics services without affecting the performance of another tenant. On the control plane side, each tenant gets a complete policy control and visibility into its set of applications. So you will see that when we do the demo, that they all log into the same controller, but they can only see their side of applications. And in this case, what happens is, as an enterprise IT admin, you can control what the policies are for each of the tenants. Let's say you have a dev tenant where you want to limit the certain amount of resources that they can consume, while giving them self-service access to creating a VIP. I mean, gone are the days where creating a VIP requires opening up a ticket with the network IT and taking hours or days or sometimes even weeks to even create a simple VIP. With Avi, it's a matter of less than 30 seconds. And the IT admin can be assured that nobody's going to step on each other. They're going to be within the policy. And the app admin says, well, I get my VIP, my load balancing instantly. So that's the kind of experience that we have created, fully integrated with OpenStack. All right, I think we've done enough talking now. Let's do some live action. So what we're going to do for the demo, and I'm going to use Siva's help here with me. What we're going to do here is we have a setup running in a Mirantis OpenStack Express, or MOX, with the Avi in the multi-tenant mode that I just showed you. We're going to do 3 or 4 different demos. We're going to do the first demo where we're going to deploy an application with Murano, as Craig talked about, where we're going to have a customer, an application being deployed as part of the Murano template in one tenant. We'll use another tenant to then deploy Avi's solution, an application with Avi's controller to show some of the advanced features that it can do that a typical LBAS doesn't provide. And by the way, you can do the same thing through Murano. We just wanted to show you a different interface for creating this. And then we'll do an on-demand elastic scale-out, as well as end-to-end visibility and analytics demo. Okay, so let's switch gear And why don't you describe what we are seeing here, Sibyl? So let me first set the stage here. What I'm logged into is, as you can see here, I'm logged into the Mirantis OpenStack Express, or MOX, and I'm in the admin. I'm logged in as an admin, but I'm also in the admin tenant, and we have 3 tenants here, admin as well as 2 user tenants. As I said earlier, in the admin tenant, we just have the Avi controller installed. We don't have any of the applications or load balancing instances. So as I can see here, this is the Avi controller that's installed in the admin tenant. Let me also show you how the user interface looks like from the Avi controller. So I'm going to log in and log into the Avi dashboard. And again, I'm logged in as an admin, and I can see there is no load balancing or virtual service configured. And I can also see multiple tenants here. So I'm seeing as an admin, the 2 tenants that I'm seeing on OpenStack Horizon dashboard are also synced here through Keystone. All right, so let's go back here, and then let's deploy the first set of applications through Murano.
Sure. So first is we want to show that the Avi package definition has been.
That's right. Let's just first log into the dashboard. So looks like this guy's timed out for us.
I99.
Let's log into the dashboard. Okay. All right. As long as we didn't find the frame. Okay. There you
Right.
go.
So the first thing is to check that the Avi Murano package is installed. And so here we have the template for the Murano package. And this one defines a very simple load balancer that creates a pool, adds members to it, creates a VIP, and assigns a floating IP to that VIP. And we are also going to use a sample web server application, which is going to be a clustered web server application. This will deploy an n number of web servers and create a cluster out of it. And these web servers are the ones that are going to get added as the pool members. So switching tenants. So we're going to use XAvi1 as the Murano tenant and XAvi2 as the Avi tenant for the VIP services created via Avi. So first is we create an environment. We're going to call this Murano created Avi. And then we add components. So as an application deployer, I would just add a web server. So here is where all the magic is. So this is, let's say, a web cluster. And I'm going to add a load balancer. I'm going to call this Murano created Avi load balancer. And let's just give it some dummy hostname. This is where we pick the cluster's flavor and the image that we want to launch. So this again is something defined by the application. So per application we can have a specific template, and each application can be integrated into a load balancer. And the load balancer template is again generic because it uses Murano's template class called load balancer. So any load balancer which implements this Murano package can be visible here, and Avi is one such package. And so the environment is created, the components have been added to this environment. The next step is to deploy this environment. And here, so this is Murano's history on and current logs on how it's deploying. I'm also going to show this picturesquely in another tab. So as you can see, it created a Murano router. So in this case, the Murano router was pre-existing, so it just reused an existing one. It created the green network, which you see called Murano created Avi Network. And currently it's adding the first web server instance to it. It also put a leg into the router. And at this point, it should also have created the pool and have one member in it. Okay, maybe it is still adding the member.
So at this point, basically we are deploying the whole application, including the application servers and the load balancing in front of it.
Correct.
Right, so we could talk briefly, if we want, about what Murano does. So Murano
Sure.
essentially is an event-driven workflow engine, so it
Mhm.
allows you to hook in these calls to Avi or other things through events that occur within Murano. And Murano naturally or by default uses the heat engine within OpenStack to
Right.
create all of these resources. So it's creating these networks, it's probably creating all the security settings and everything on those networks, and spinning up the VMs and hooking it all together for you as a user, so you don't have to take care of creating all this infrastructure that you're seeing dynamically shown here. And critically, these templates are extensible, so enterprises can tune them to do exactly what they want them to do,
Mhm.
right? It's not some sort of black box.
Makes sense, yeah.
So here we see the current status. So what happened is it created a network, put a leg into the router. It created the first instance, and when it did that, it also created a pool. It added that instance to the pool, and then it created a VIP for it.
Mhm.
And the second instance also got added to it. So when this VIP was created, all of these components get pushed into the Avi controller. And if we switch tenants here, we should see the service come up in a few minutes. It's right now deploying the service engine, which is going to perform the load balancing.
As you can see here, everything is getting synced from OpenStack into Avi because of our integration with Nova and Neutron.
This management network that you see is, we have a leg into the management network, and this is for the Avi service engine to talk to the Avi controller. So as Ashish showed in the previous slide, wherein in the admin tenant, we have the Avi controller attached to the Avi management network. So the same management network is shared across tenants, and based on the deployment, you can make this private. This, for the sake of demo, we made this simple and made it as a shared network.
Yeah, you could have a private network and use floating IPs then to talk to each other, or routing to talk to each other.
Exactly. So let's see if the SE is up at
Yeah.
this point.
Yep.
Okay, so there you go. The VS is up, and if you go to the dashboard, so because we created all of this through Murano, the Murano server also prints out a thing that says what is the current floating IP associated to the VIP. So in short, the Murano template along with the Avi template helped us create a whole application and assign a floating IP to it all in a bunch of clicks.
Got it.
So if you go,
So you can actually open up a
Graphic,
browser.
yes.
Yeah. So let's do that. So let's open up a browser tab and take this IP address, which wasn't this one. It's already copied. Go here and paste it. Oh, it's the
Oh.
wrong one. So let's go
Oh, yeah.
here and copy this. And let's set this in action. So in this case, where'd it go? There you go. So at this point, we've actually gone through the VIP and accessed the backend server. And we can actually see that in our analytics on our
client
and the client logs, and let's make it real time. Let's bring in all the logs, and we should be able to see the transaction that we just did, which is right here, which is we access the home page, and I was running, as I see, I'm running a Mac OS with a Safari browser. I'm in the US. I took 62 milliseconds to hit the MUX load balancing instance that I was running. The backend, the latency between the Avi load balancer and the pool server was just less than a millisecond. Application, the Nginx server took 30 milliseconds to process, and there was nothing to send, nothing much to send, so zero data transfer time. So within the last couple of minutes, we have gone end to end from deploying the application, deploying a load balancing instance, running traffic, and seeing it live in front of your eyes for this. So excellent.
That's super cool.
Yeah. Now let's do the same. So this is giving a little bit of an idea of what Avi UI looks like. But if you want to create an SSL VIP, which today LBAS doesn't provide, or if you want to just create advanced features, can you show me how you can use Avi's UI to create a VIP?
Sure. So we'll switch tenants and go into the X-Avi tenant. And the reason I'm switching is just so that the UI is clear and it's like basically starting from the scratch. So we'll switch on the Horizon dashboard as well. And just show the topology. The topology is very clean at this point. The setup is the same. You have a client, you have a backend web server, and we are going to create a load balancer to this backend web server with the VIP in the client network. So let's log back into Avi UI. Let's go to the dashboard and say create. So we're going to use, for the demo, we're going to use a very basic setup. So if you want complicated features like SSL offload and SSL pass-through and all of these, you can go into the advanced VS creation. For the sake of time and the demo, we're just going to do a very simple. So we're going to call this Avi created VIP, and I'm going to give it an address of 172.24.200.100. And I'm not picking this address randomly. I'm just picking this address from the front-end network. So the front-end network is 172.24.200/24, and I'm just picking addresses from 100 onwards. And we do select servers by network.
So this is actually very interesting what Seva is doing, which is because we are fully integrated with Nova and Neutron, we can actually query what are the backend servers that are available, what are the web servers that we can add automatically in the pool, and just add it. So instead of manually configuring the IP address of their Nginx server, we can actually pick it up from a drop-down menu.
Exactly. So you need not remember the addresses, and you just pick and choose.
Yeah.
So we hit save, and
at this point, what's happening on the OpenStack side?
correct. So the behavior is still the same. So whether it is coming via LBAS Avi Murano to LBAS to Avi controller, or it is coming via the Avi GUI to the Avi controller, it's all being called as REST APIs. And in the end, the result is the Avi controller talks to Neutron and spins up a load balancer instance. It creates security groups, opens up the right ports for the traffic to flow through. It also registers the Avi service engine with the Avi controller.
Right. And as you can see here, while we were talking, a new SE got created, put it in the right network. So again, Avi controller managed that. This instance is still being deployed. And now it's just active as I'm speaking. It's in 3 networks. The management network for talking to the Avi controller, the front-end network for taking client traffic and for the VIP, and then the pool network for going to the Nginx server, for the backend pool server.
Correct.
And if I go back to the Avi controller, the Avi service engine should be now ready in a matter of seconds. And because at this point, the Avi controller is still talking to the Avi service engine, making sure it's all good. So within a few seconds, this should come up. So this shows the power of integration between the OpenStack and Avi solution. Whether you have your deployment done through LBAS, through Murano, for example, or through Avi controller, the integration with the OpenStack components is consistent. Oops. Let's go back here, and this should be coming up in a matter of seconds. So maybe it's taking a few extra seconds. So let's wait for that. While we wait for this service engine to come up, we have a couple more minutes that I want to talk about the visibility piece, and which is very important because so far we have done the load balancing set of demos. I also want to do a visibility demo. So I'm going to log into a different controller, a different setup where I have some more traffic running. So I'm going to log into my Avi controller, and this is a different setup where I have 7 or 8 or so apps configured. So let me go to that, and in this case, what you see here is you should see about 8-9 VIPs configured for different applications. The first thing you see is a color-coded health score. In this case, green means it's reasonably doing fine. Yellow, well, there is a warning. Orange and red, well, something is wrong. So in this, also there is a score that says the health score, which is a measure of the application performance and end user experience. any resource penalty, which is the measure of infrastructure health, anomaly penalty, which is a measure of any abnormal behavior, and a security penalty, which is a measure of any security issues, including policy misconfiguration. So I'll quickly show you a couple of things here. As I go into this application, the first thing you see, and you might have seen in the earlier demo, but with a larger set of traffic, this is more apparent, is an end-to-end timing dashboard. This is something unique to what Avi does. No other solution today provides an end-to-end latency diagram without any agents, without any monitoring fabric or span ports. It is inline analytics, and basically what this is telling you is that on an average, over the last 6 hours, my clients are taking about 36 milliseconds of round-trip time to come to my data center where the load balancer is. The latency between my Avi load balancer and the server, it's a millisecond and a half. Application is taking about 50 milliseconds to process the request. And the data takes less than a millisecond to go out with the end-to-end latency of about 90 milliseconds. Now, this is a very powerful tool for a network admin. We call it a mean time to innocence tool. And the reason is that typically, if you're a network admin, you get blamed for any performance issues. When a user complains my app is slow, when an application guy says my app is slow, it's usually the network. Well, this dashboard tells you what is the latency breakdown at every location. And whether it is the network, in this case clearly it is not, or the application or something else, you can do that kind of analytics very, very quickly. We also do color-coded breakdown of various latencies. So the orange is the app response time, the green is the client WAN RTT, and as you can see, the data transfer time or the server RTT is very minimal. So this is a very powerful dashboard that is very useful as you deploy your business-critical applications in OpenStack. There's another kind of analytics that you do, which is the needle in the haystack kind of analytics, which is if you are looking for a particular transaction that's slow, or if you're looking for a specific set of types of transactions, can you do that type of analytics quickly? And so first thing you see is you have a Google-like dashboard for the client logs, and I'm just waiting for my logs to appear on my dashboard. I guess there are about tens of thousands of logs, so it's just taking a little bit of a time. But this Google-like dashboard then allows you to then query or search your logs quickly. So for example, I have about 30,000 logs here, right? And I can do things like, show me all the logs which are from iPhones. And if I do a contextual search like that, just say, show me only iPhone logs, quickly it'll show you only those transactions which have come from iPhones. And I'm still waiting for it to load. Give it a second or two and it should come up. But this is very powerful as you're trying to do analytics on your application workload. Looks like things were timing out. So let's come back and go to a different application and see. Let me go to a Scaleout. So in this case, okay, so this is a different application where I have a more colorful dashboard where I have different latencies. But an interesting thing here is that I have a resource penalty and a security penalty. And in the interest of time, I'll just do a quick Elastic Scaleout demo, which is, in this case, the resource penalty is tied to the fact that my infrastructure resources are saturating. So if I just click on that, as you can see here, my average CPU utilization is almost 100%. In a normal environment, what I would have done is I would have automatically scaled out my load balancing instances. For the purpose of demo, I'm going to manually scale out. So instead of one VM, one service engine VM providing the load balancing capabilities, by just clicking on scale out here, I'm able to spin up a new VM and automatically add a new service engine. So that is the power of elastic load balancing. Any final thoughts before we conclude here? I'm back to my OpenStack whip, which we had created through Avi. It's come up, and looks like it's running some traffic as well. No, right now we don't have any traffic going on. And going back to the Horizon dashboard, the full load balancing is up.
My thoughts are that basically this kind of visibility into what's going on in the network for specific applications is exactly what our customers need in order to understand how they're delivering value to their customer and how they can tune their infrastructure to get the most out of it.
That makes sense. So let me see if I was able to get some of the client logs up here.
The demo gods notwithstanding.
No, demo guys notwithstanding. So while we do that, let's summarize. I think we're just about running out of time. So I think in this webinar with Mirantis and Avi, what we have shown is how do you build enterprise-grade OpenStack cloud and deploy them and provide visibility, availability, security, and elastic scalability for guaranteeing business-critical application SLAs, for reducing risk with an on-demand scaling infrastructure, and basically how we can help you accelerate OpenStack cloud adoption. Our contacts are here. You can check out, you can do a free trial, by the way, with Avi on our website. You can just download the code in your environment, or you can see it in an interactive lab for a sandbox experience. And we have a bunch of collateral on both with Mirantis and Avi. And you can meet us at the OpenStack Vancouver Summit. We'll have some more interactive demos and talks.
Yeah, I'm looking forward to talking to both our customers there. It's going to be a lot of fun. Come visit us in Vancouver.
Thank you, Craig. Do we have any questions at this point? Let's see if we've got any questions. So looks like there are no questions here.
It's good. We hit all the points.
We hit all the points, so that's great. Well, thank you very much, everyone, for joining us. If you have any questions after the webinar, you can reach us. Our email addresses are here. Also, you can reach us through our website. And thank you for joining us. We will be sending out a recording of this webinar to you.
Have a great day, everybody.
Thank you.